jacketing here. We're finally getting 2021 season off the road. Off to a good start. We're here at Verus Engineering, doing some very, I was gonna say secret special, but it's not really secret special anymore. We're making this happen. This car has already been 3D scanned. From here, we're going to do a lot of analysis to do using the 3D scanning to build this CAD model. Very nice thing about Verus, they already scanned their whole car and they have developed multiple Aero kits and versions off of this car. So what it is basically now we're just going to scan the things that are different on our car with a Spaceport kit and use the data that they have, do analysis, and then optimize everything that we can on this car, whether it be changing rear wing position, whether it be changing to a whole new rear cord with a stage, bigger tunnels at the front, different tunnels at the front, side skirts, rear diffuser, everything we can get our hands on, we will. And I think that's really where the Supra has the next sort of evolution, right? It's to better balance out the aero and create more usable aero and minimize a little bit of drag. Everything that we can do, we're gonna try. The way we look at the development curve of the Supra now, there's only so much we could do with the weight. You can't trim out 600 pounds overnight, unfortunately, not in street class. But aero is always an area that I feel like we can improve upon more. And I think it's the area that maybe if a lot of our competitors aren't taking full advantage of. And that we will absolutely do everything in our power and maybe a little bit more to hit the limit of the rule books and beyond, to infinity and beyond, of course, to try and push this car to be the ultimate high-speed track time attack machine. I think can do it. Maybe not at a track like Gingerman, maybe not like a track like Mid-Ohio, but things like Road America, Road Atlanta, Buttonwillow, even Coda. This is where we want to excel, and we're gonna really focus on that. So, 2Gs of cornering on street tires, anyone?
That sounds bad on the oil system.
It's not super, man. What are you talking about?
The following Thursday,
We're back at Verus Engineering, this time with the actual working model and having some baseline results of how the TA90 V2 has been running all year.
So this is the overall CAD model. So we took this from our original scan of our car, and then we scanned specific parts of Jackie's car and implemented that into the model. So you can see the fender vents, the hood vents, so it's a totally different hood. The whole front setup with the splitter, the rear wing, the splitter on the underside for all the mounting, and the diffusers, and then it's also running our diffuser and the single exhaust. We're also testing it with the windows open, seats, driver, steering wheel, because most of the time the car is raced with the windows down to give it a more realistic aspect. So we are also simulating coolers on all three, so you have a center cooler and then two outside coolers, and then the brake cooling duct also goes through there and then through here, so you can see kind of how airflow and then wheels and brakes and all of that good stuff. So
this is like a really reasonably accurate model of how we expected. Like, this looks just like the car, it's pretty cool. So
yeah, and then from there we ran CFD, and so these are, it's kind of like what we're looking at. So after we ran CFD, this is the post-processing. This is a program called ParaView. This is what we use to look at all the data. So kind of what you're looking at right now is just, this is a basic velocity cut plot going down the center of the car, or fairly close to the center, and then on the surface of the car is actually a pressure plot, so you can still see the driver inside of here. The low pressure side on the bottom side of the splitter, you can see more of what's going on and how everything's flowing around. You can see how it interacts with the grind plates, the mounting brackets, the diffuser, and then you can kind of see what's going on with like the end plates. And then the air coming out of the vents. And so I have a whole bunch of basically streamlines that specifically show kind of what's going on in specific areas. Like one area you guys were wondering about is how the air comes from the end plates, that bottom part.
Yep.
So this is specifically, basically I put a ball right there and it tracks basically at that point where it comes from and where it goes. So that's kind of how this operates on these. and then this is the other one. So they're a little bit different side to side, obviously, because so like I told you, when we test it, we actually flow the air a little bit at yaw. So this is the 1/2 degree. So this shows you the difference between the air going in this way and then coming around this way.
Yeah.
So it makes a pretty big difference on kind of what's going on with airflow. And then this is coming out the fender vents. So as you can tell, most of the air that's coming out of the fender vent is actually going through that right-hand cooler.
That makes sense. Yeah.
And we've actually noticed that on other cars. A lot of times that if you have coolers on the side and you have fender vents, a lot of the air that's coming out of the fender vents actually is coming from the cooler. See how that operates. And then all the other ones are, let's see. Oh yeah, this is, I basically put kind of a ball inside the cab so you can kind of see what's going on, because this is one of the first times we tested inside the cab. So you can kind of see basically what's going on is what that is it's a big dead water region. And I can get rid of the car so you can kind of see. So basically it kind of just fills in that void, and you're not getting a whole lot of crazy airflow. I was actually surprised on the overall difference between windows up and windows down. I thought it was going to be a lot worse. It really isn't.
The air is, one of the inside is kind of just like trapped inside and sealed itself.
Yeah,
Right?
pretty close. Like it's not fully sealed, so you're still going to have some difference, but pretty close. I thought we were going to have a lot worse interaction with the rear wing, which not the case. Rear wing basically makes about the same amount of downforce.
Wow.
So that was zero issue, and you can kind of tell like even the air that's coming out isn't interacting really with the rear wing at all. It's much lower.
Yeah.
Through the hood vent, as you can tell, most of these are coming from the center radiator.
Yep. That makes sense.
Let's see. So one thing you do have to be concerned about when you do hood vents, yours I wasn't too concerned because I saw where it was on the side. It's actually fairly far forward, so it doesn't have as much of an impact further downstream.
Yep.
Some, when you have like the big giant louvers in the center, and depending on how that first gurney is or some of the first flaps, you could actually send this airflow very high up, and it can hurt the rear wing. But obviously, right here, there's really not any problem with that. So
Cool.
Overall, the airflow to the wing is good. Realistically, we probably actually lower it if we. I don't know if it would actually matter on the area side on this. Given if we lowered it a little bit, see, the main thing you're only going to do is you're going to decrease the area a tiny bit right here, but you're not going to decrease the area a ton.
Yeah.
So realistic, I'd probably leave the wing where it's at. The only benefit is if we lowered a little bit, it'd give you more room for angle of attack change and not increase area to the car. So that's one.
Right. But right now we don't really need more angle of attack on the rear wing anyway, do we?
No, you do
Yeah.
not. So that would be something though if you did eventually want to look into that.
Okay. Which is like
that's
the
an
whole
option.
like that is something we're gonna get into really shortly with the data actually. But feel free.
And so this is kind of like the main area like we look at on the car, pressure plots, so we can kind of see everything that's going on, top, and so this is, you can see the difference. A lot of times if you don't have hood vents right here, you'll actually have a much higher pressure region all along here, but because the actual air coming off the vents kind of spills around the side, you only get like a high pressure pocket right here. So a lot of times when you reduce drag on hood louvers, you're thinking, okay, yeah, it's decreasing drag because you're actually lowering pressure and it's getting easier to go through the cooling stack, but you're also decreasing pressure actually on the windshield because it's changing how the air flows around the windshield, which is beneficial. And you can see this whole top section, it's lower pressure, which is good because that's where actually the air is being extracted, so you want that to be
Yep.
low
You
pressure.
want that low pressure, yeah.
And so, like, where I have it right now is basically everything that's kind of grayish is anywhere between 0.2 and negative 0.2 on the CP plot. So that, because a lot of those areas around 0 aren't really that important to us because we're looking for the areas of big change. So that's what we're going to focus on first. Makes it better for actually visualizing kind of what's going on.
Yeah. Easier to identify the problem area if you like, right?
Yep. That's always my favorite, where you can see the difference basically between where it goes from positive and negative, that outside
Yeah,
ring.
it's the whole ring. Yeah.
Does that mean kind of we can almost move the wing a little bit more forward?
You could. There's two rules of thought behind a lot of that.
Yeah.
So there's benefits and negatives with the duckbill.
Yeah.
The benefit is obviously it increases pressure upstream, which you can kind of see.
Yeah.
So what that does is obviously that decreases the actual lift force
Yeah.
coming on the top side.
Yeah.
Awesome.
That's without the wing, obviously.
Yeah.
Yeah.
And the only negative is it does have usually a negative, not always, but usually a negative aspect on the wing if it's not placed correctly.
Right.
It would be hard to know if the wing would perform better unless we obviously moved it. We could probably move it forward a little bit without hurting much. So like where this is right here, we could probably put it to like right here maybe.
Yeah, that's kind of what I was thinking because it seems like the center of like the low pressure is behind the center of high pressure from the duckbill. That's kind of what I'm looking at right now.
Yeah, so we could definitely move it forward. The only inherent negative drawback to something like that is
You're losing the high pressure on the duckbill.
you're losing more of the high pressure on the duckbill, and you're losing some of the efficiency of the wing itself.
Right.
However, you're more concerned with having front downforce than rear downforce, so that's not always a huge deal, but you are kind of inherently losing some of the efficiency that you could have had on the wing. There we
Green
go.
is slower, right?
Yeah, bring it
yeah.
slower or stalled. Yeah.
It's interesting.
Yeah.
You can really see the boundary layer and everything though.
Yep.
Yep.
Yeah.
So, and this shows you, the cool thing about this is, so I really like basically LIC plots. That's what this is. This is like what you would have on the body of the car when I was talking about the oil flow. It's really cool with stuff like this because you can actually really see what's kind of going on around like the wing and stuff. So you can see that little pocket behind the rear right there. That's from obviously the gurney.
Yeah.
But you can see basically how the air flows down and then how it's flowing down and then loops around there and kind of comes up.
Yeah.
So that's where you could start to see. So if we pulled the wing off and ran it, you could see how the airflow comes off of here. And then you could actually, what's kind of cool is you could take a picture of this, put that picture into CAD, scale it properly so like the body lines up, which would be pretty easy. And then you could actually work on placing the wing in good, clean airflow. But moving it forward, I don't think, like we could probably move it maybe up to 50 millimeters forward if you wanted to. This is specifically drag related, so we can kind of see where things are for drag. So you can see kind of like, obviously, this is why wings are usually pretty inefficient, is all, basically anything past that edge where it starts to curve up is all creating drag. You have like a minor thing right here, which is probably from the upright, but very, very minor. Yeah, you can see a little bit towards
the
it.
outside still kind of curves out.
Yeah. So you do lose a little bit. So yeah, which that's pretty much how ours are. Just because like obviously near the end plates you're gonna have the best performance. I don't.
Hold on a minute. Does that mean the Subaru boys with the in the middle of the STI wing? Does that mean it's helpful?
You can see it right there too.
Yeah. Very clear line.
But if you had uprights on the bottom side, it'd be way worse.
Yeah. Is there any way that we design an end plate that's very specific to the range of angle that we will be running, just to make sure like it work really, really well, but only in that range?
Yeah,
Because that would help, right?
Yeah.
So we just design an end plate that will work really well, say between 0 and 5, which most likely will be the range we are working at.
Yeah.
That really don't care how it perform over 5 degrees.
Exactly, because honestly, we're designing this rest of the Aero Kit now for this car.
Yeah.
For this very specific
we know
car.
we're probably not gonna
Yeah.
go crazy and go attack.
Yeah.
So if we can optimize something, yeah.
Ooh.
So this is our off the shelf one. So this isn't gonna work for yours, but this gives you the idea of kind of what it is. So basically, if you add vents to the top side, so up here, what that'll do is it bleeds some pressure off the top, which decreases some drag. You will lose a little bit of downforce, but not crazy. And then what that does is that air actually comes out from there and actually helps reduce the vortice coming off the end plate, which helps reduce drag. So that's
the overall size of the vortice. Right?
Yep.
And also you use a slot on the back end to control where the vortice starts.
Yep. So doing something specific like that will decrease drag.
Yeah, that's kind of.
on doing that though is it probably wouldn't be too bad if you want to 3D print the mold for that, because that probably wouldn't be too bad if you 3D printed it.
It'll be a lot cheaper than a new wing blade for sure.
Yeah, and then you just have to cut the slots, probably by hand, but that wouldn't be too bad depending on how you actually design the mold itself. It might be fairly easy to actually cut out. Doing just slots though usually doesn't work as well.
Yeah, you need to do like
You need like the louver.
Yeah, you actually need to louver it in and actually have it designed
give
so
you like a little bit more directional, because you want to do louver in, so all the high pressure goes this way out.
Yeah.
Right. So if it's a louver, it just kind of seals it sometimes.
yeah, and if it louvers out, it's actually going the wrong way.
Yeah. Then
So
you make it worse.
yep.
understood.
So that's why all the Formula Ones have it louvered.
Yeah.
Yeah.
Not just like an open line,
Yeah,
open
you
gap.
need a louver too.
Can we first do like a comparison between the downforce figures of like bone stock to now, and then drag figure
That'd be
between now, like bone stock to now?
Yes. No, at least we know the car's making downforce.
It is making down.
It's not like we.
Trust me, dude, I feel it.
I know. It's
Yeah,
like,
The car makes, I would say, pretty good downforce for. It obviously doesn't. It's a race car, but it's not like. You don't have giant wings all over. It's a single element. It, in my opinion, makes really good downforce for how it's set up.
Yay.
We've done a good. Alex,
Shout out to Space Sport.
shout out to Space. Space Alex has done a good.
All right, so this is what we're looking at. So this is the stock numbers. So drag, you're going from 549 to 899.
Huh.
So about
250 pounds?
yeah. These are newtons.
350 newtons.
350 newtons. So I have two different baselines. I have baseline here and baseline of when we lowered the car.
Yeah.
So we just lowered it a little bit. So you're looking at a difference between 22 pounds of lift versus 27 pounds of, or 27 newtons of downforce.
Oh, that would be
So
just
it'll
from
be
the ground
very
effects. Eh?
neutral. That'll
Yeah.
be like almost like
Okay.
very
Yeah,
neutral. No
with the
downforce
amount
whatsoever.
that makes, I would assume based on different areas of how the car's supposed to perform, they designed it to be neutral.
Yeah.
Yeah, so it's a zero.
Yeah,
We'll do
I
the-
would say it's designed to be somewhere around zero because we're obviously testing it in one specific scenario.
Mhm.
Cars go through a ton of different scenarios, so it's going to be as close to neutral as possible. So if we go based on mile per hour and pounds, which is the easiest people are going to be able to look at, so you'll be making about 500 pounds downforce at 100.
Not bad.
316 pounds of drag at 100. So just looking at the coefficient of drag, it's high, but not for a car with a wing.
Oh,
When you start adding wings to cars, cars are not in the 0.3 range.
yeah.
Like most people will claim like stock factory coefficient of drag.
Like 0.26 or whatever.
Yeah, that would be really good.
3.35
'Cause-
is typical.
Yeah, because remember OEMs when they put out their numbers,
Yeah.
they're putting it in the most optimum range possible.
That's true.
Which, of course, anybody who's designing something and putting numbers out are most likely going to put the most optimistic numbers of during their testing. OEMs are no different. From people I've talked to at OEMs, that's kind of what they do. So if they're saying 0.26, it's probably more likely 0.3
Yeah.
on the average day-to-day driving. The factory car was 0.313 or 0.31 or 0.337.
That's not
So
bad, yeah.
right in the 3 range. That's it's better than actually what I thought it would be.
All the fake vents help.
Yes.
Yeah, for once, actually, yes.
Yes. Yes, we know this. Anyway, continue.
So like comparing to like say an open wheel car with like wing like Formula One or IndyCar or anything like that, those cars are usually higher than 1. So looking at it scaled wise towards that, you're a lot closer to a factory car drag wise than say an open wheel car. Open wheel cars are not super also efficient.
To be fair, that's what it is. It's a bone stock car with freaking wings bolted onto it. You
Yeah.
know it's true.
So that's why you're in that kind of range. I would say like you could definitely make it more efficient. Like you can definitely make a lot more downforce and keep around that same number. Lowering that number becomes tricky just based on having wings.
Yeah.
However, I think we can decrease drag on the splitter. The wing itself, it's going to be really hard to decrease a lot. Like the end plates, I think is a good idea. I didn't even think of that, but that would be a good place to start on the wing side of thing to lowering that, maybe even lowering the wing like 25 millimeters in
That's
there
kinda what I was leaning
and
towards.
seeing also kind of what that does. As some different options to try to figure out how to get drag out of the car. Also, the custom diffuser setup's probably going to help also on that fact, just helping fill in the void behind the car, just because you're going to be able to cut out that plastic, gives you more room to work with.
Perfect.
So those are
Right? Yeah.
We're gonna run that way high.
so there's definitely ways to do it like that. The problem usually though is the bulk of the numbers are coming from the body of the car. So taking the body of the car is 0.33.
Yeah.
So you're left with 0.2 to work with. You add a wing, that automatically is going to have a big chunk of that. So you're working with a much smaller range. Like if we were really good with decreasing drag, you might see a number maybe at like 0.48 type of thing. It's not going to be like a drastic drop down.
Yeah, it can't. It
Yeah.
really can't. So rather than that, we can focus on things that we can maybe feel more. Like one of the things I really want to point out was the downforce balance front and rear. Because all season long, you could see me in the high-speed corners, like trying to push through understeer.
Yep.
And the numbers kind of checked out.
Yep. So on the balance on the front, so that's this number right here. So the top number is with the windows up, by the way. The other number's with windows down.
Yeah.
So we're at 30.5, which I would say for most amateur drivers, that's actually not a too bad of an area to be, just because they like a lot of rear downforce.
Yes.
But you drive your car more like I would say more like a professional, somebody who
Me no likey.
likes you like a lot more front downforce. So you're gonna want to be much closer to the 50
I prefer
range.
Yes.
Yes.
I just want the car to turn and then it goes instead of like turn and it's
yeah.
that waiting process. That's what kills me for time. So if we get that number closer to 50, like maybe more important than the actual like overall downforce number, like oh we need this amount of downforce, this amount of the drag. If that number gets closer to 50, if the balance gets better, I think I can wheel the car harder if you like. So,
Well, we could easily get to closer to that range with probably keeping the drag fairly close, just because of changing up the front splitter.
the car, like right now in the static ride height, is 30% downforce balance of the front.
Yeah.
But we know from experience,
Yeah.
the car likes to be at, like when you're throttling hard, the rear sinks in like a
So
lot.
it probably gains like a degree or so.
You probably lose a ton of
More,
front
more,
downforce.
Yeah.
more than one. It's
Yeah.
definitely more than one or two.
Depends on when
Yeah.
you're like diving decel into a fast corner
It's-
or you're accelerating
whoa,
outside the
whoa,
fast
whoa,
corner,
whoa,
right?
yeah.
So it's like say riverside, it's the first half of the riverside
Yeah.
versus the later half of the riverside.
Yeah.
Because you're in corner, you're almost never at this
0 degree.
0 degree.
Yeah.
You're either decelerating or accelerating.
Yeah.
Yep.
So if let's just put it this way, if it's only at 30% front downforce at static, then it's
Well,
not good
on
enough.
throttle is going to be a lot less. Than
It's gonna be
Yeah.
like 10%.
yeah.
Yeah, if you're lucky, it could even drop more than that. Because like
Really?
I like to see it, what the number.
because it really depends on like, so you have like, it's called like a ride height potato type of thing. So
Yeah.
it's like, because it kind of looks like a potato when you graph it. That basically shows like how the actual car is moving around corners.
Mm-hmm.
Well, a lot of times if you're having the front lift up a lot,
A lot.
a lot.
then
a
you
bit.
are basically losing almost all of the work the splitter is doing.
So what we're saying right now is some of the air is instead of staying out from underneath the car, it's
Yeah.
going in, right?
So if
Yep.
like
And this isn't even accounting in like the car rolling and pitching.
so this is effectively on a right hand turn.
Is it?
No,
No,
it's
left.
gonna be a left-hand turn.
Oh yeah, left hand turn.
Oh,
I'm 90% sure this is supposed to be right hand turn.
Okay, so air is coming this way. I
Yeah.
turn this way.
Yeah,
Air hits this way.
because
I guess
remember slip angle, so your rear
Yeah,
was
you're
stepping
right.
out, right?
Okay.
That's why this angle attack, because your rear slip angle is stepping out. So this should be on a right hand turn, so the air is slightly coming this way. Think about oversteering. Think about counter steering drifting. Then it makes more
Air
sense.
hits you this
right?
way.
Right?
Anything with counter steer makes sense.
Yeah.
See?
So this should be a right hand turn.
Okay.
So this is when the lower side skirt, to prevent some of the air from going in or redirect that, would help.
Correct.
You know what?
And just a side skirt coming out here just would basically prevent any.
Yeah.
So that's when you increase the angle, that's where, like when I was saying, you don't really notice the difference of like side skirts until you start running different
Yeah.
yaw changes.
Yeah.
That's why. Yeah.
That's pretty much why.
Yeah.
Okay.
So if we can kind of seal some of the airflow that's trying to
Underneath
go
the car.
underneath the car.
Yeah.
So did you do a path about that ears kind of going over the front end plate? Because it's going to be a vortice there, right?
Look at that.
Yeah.
Oh shit, Alex's knowledge is actually useful.
I'm like CFD in here.
Computational fluid dummy.
You see,
Yeah,
like you
drew
see
it up.
why it gets sucked in, because that vortice, that rotation is sucking it inward.
Yeah.
Yep.
Yeah, they're sucking it into the car
Yep.
that way.
Yeah. So if we can reduce that vortice, first of all, we're probably going to reduce a little bit of drag,
Yeah.
and then second, we're going to prevent some layer to try to kind of get
Underneath
sucked
the
into
car.
that vortice and get sucked in.
So like the whole point of this vortice was like, what is the point of this vortice to begin with? Then?
What do you mean?
On the end plate. Why?
If you have a kind of like a tire spat in the splitter, there's almost guaranteed there's gonna be a little vortex there.
Yeah.
It also helps if you can manage it correctly. The vortex actually pulls the high pressure air in the front wheel wells out. It helps kind of
That's true.
reduce the pressure. But the only downside is because it's always going to be rotating. Like on this side of the car, it's always going to be rotating this way. So it might kind of suck more in and try to get on the side of the car, which is exactly what's happening over here. And that's why I think you see it's not like going straight in. It's like curve down.
Yep.
Right. So as the vortex kind of expand level, it's going to start get the air like around it to do the same thing. And that's how it gets like curvy, then suddenly gets sucked in and just goes into.
And then with the tire spat, honestly, I'd probably just get rid of that whole top side of the end plate.
Oh yeah.
Because your most of your battles on the top side is going to be solved with a spat, in my opinion. I think you could the end plate, then this area serves a purpose of helping sealing the sides to keep it low pressure. But in reality, if you're putting a tire spat there, given it would be beneficial to test both ways, but I would look into maybe chopping the top off and changing how that is, and you might not have that big of a problem.
Sure.
The splitter, like the end plate, could be making more drag downstream with that on there, so it's always a good thing. Like what it's doing now, though, it's designed to actually work properly, but with tire spat, it might totally change how that interaction
And have to
is.
investigate how exactly does the whole system work
Yep.
later when we add like a tire spat in.
And that's a cool thing here. We can experiment in the virtual world of wind tunnels, and have Paul here do all the testing.
Before you actually build expensive parts.
Yeah.
Yeah.
These parts are very expensive
They do get expensive.
and time consuming to build, time consuming to put on the car.
Yeah. And this
Time consuming testing to make sure everything's working properly.
Huge pain in the ass loading, unloading.
Yeah.
Yep.
Yeah.
So it's always good to be able to do as much testing ahead of time as possible.
So even as we speak, even as I'm at home and sleeping and AMS is busy trying to fix the car is running on a virtual racetrack right now, getting wind blown on it, and we're getting data. It's the cool part about this. This is why F1 engineers don't go home during winter. They don't see family. They don't have
Just, like,
holiday.
slavery.
It's
into
like
the
September. It's like
HQ, just-
September to like February is slavery.
I will take you